Good evening, students. Today we are going to start chapter 10, Wave Optics. In this chapter, we will study about the wave behavior of light. The wave behavior of light was first predicted by Sir Isaac Newton by his corpuscular theory of light. According to this theory, light travels faster in denser medium and slower in the rare medium. This was the big failure of this theory because later it was discovered that light travels slower in denser medium and faster in rare medium. The actual wave theory was initiated by Sir Huegens, but he assumed that light travels in form of wave like a longitudinal wave, like sound. This was again the failure. Later, Young's, Fresnel and Maxwell worked together and established the wave theory of light. According to Sir Louis Victor de Broglie, light is a wavicle, means light is wave plus particle, means it has dual nature, dual character. It behaves like particle at times and it behaves like wave other times. So this is the wave nature. Wavefront. Basically, we know light is emitted by any source. The source emits light in all directions at regular interval. If I assume all the particles generated at the same time are traveling in the same in all directions, if these points are joined by a continuous path, then this is called locus. So what is wavefront? Wavefront is the continuous locus joining all the particles emitted by a light source and vibrating in same phase. So in short, wavefront is the locus joining all the particles vibrating with same phase. Types of wavefront. How many types of wavefront do we know? Depending upon the nature of source, wavefront can be of three types. First are spherical wavefront. If source is a point source, then wavefront will be spherical wavefront. Number two, cylindrical wavefront. If source is a linear source or cylindrical source like a slit, then the wavefront will be cylindrical. Number three, plane wavefront. If distant point source is there, means there is a point source but at a large distance, then the wavefront which was initially spherical turns out to be the plane wavefront. So plane wavefront are produced by distant point source, cylindrical wavefront are produced by linear source, and spherical wavefront is produced by point source. Now let us see how shall we represent. Suppose this is the source of light. At the center I have assumed a source of light that is emitting light. Suppose the first batch of light particles is represented by the innermost circle which is shown by green. When this circle spreads out, the second batch is emitted. When second batch comes out, the first batch goes on the blue path. So this way I will show the concentric spheres around the source. These concentric circles or spheres are the wavefront. This is the representation of spherical wavefront. The straight line represents the rays. Rays are the virtual path of light and which is always perpendicular to the wavefront. Here I am showing the cylindrical wavefront. These are coaxial cylinders. First wavefront, then second wavefront, then third wavefront, then fourth wavefront. This way light is propagating. The direction of arrow or direction of ray shows the direction of propagation of light. So this is the cylindrical wavefront. If light source is distant, then the plane wavefront are taken as the planes parallel surfaces as shown in figure. Here I have taken parallel faces at equal gap. This represents plane wavefront, or sometimes we can simply represent by drawing the parallel lines perpendicular to the rays. So this is the plane wavefront. Now types of spherical wavefront. Spherical wavefront can be of two types. If the light is getting away from the source, then this will be the figure. The green surfaces are the spherical wavefront which are diverging as the ray are diverging from each other, means it is showing the divergence of light. So this is diverging spherical wavefront. But if light is coming to concentrate at a point, then rays are pointing inside, and such a spherical wavefront are called converging spherical wavefront and shows the convergence of light. तो ब्लू पेन से जो यहाँ पर दिखाया हुआ है वो स्फेरिकल कन्वर्जिंग वेवफ्रंट है, जो यहाँ ग्रीन पेन से दिखाया है वो स्फेरिकल डाइवर्जिंग वेवफ्रंट है. नाउ वन इम्पोर्टेंट टर्म कम्स रे. व्हाट इज रे? रे इज एन इमेजिनरी पाथ ऑफ लाइट which shows the direction of propagation of light, and a ray is always perpendicular to a wavefront. किसी भी वेवफ्रंट पर रे हमेशा परपेंडिकुलर रहता है. Here we have to pay attention to few important points. Number one, in case of plane wavefront, rays are parallel. जब wavefront plane होता है तो सारी rays parallel होती है, and we know the bunch of parallel rays is called beam. So bunch of parallel rays is called beam here. Number two, time taken by a ray to reach one wavefront to other in all direction. ये रे जितना टाइम ले रही है उतना ही रे ये लेगी, इतना ही टाइम ये लेगी. किसी भी डायरेक्शन की मैं बात करूं, एक वेवफ्रंट से दूसरे वेवफ्रंट तक जाने के लिए रे टेक्स इक्वल टाइम, या वी कैन से टाइम टेकन बाय अ रे टू रीच वन वेवफ्रंट फ्रॉम अदर इज सेम इन ऑल डायरेक्शन, एंड दिस टाइम पीरियड इज अप्रोक्सीमेटली 1 शेक 10⁻⁻8 सेकेंड. तो मोस्ट कॉमनली वेवफ्रंट्स आर जनरेटेड एट अ गैप ऑफ सेक. एक सेक के बाद जनरली अगर स्पीड ऑफ लाइट इन वैक्यूम की बात करूं 3 लाख किलोमीटर पर सेकेंड है, तो इन वैक्यूम एनी टू वेवफ्रंट्स आर जनरली डिफर्ड बाय 3 मीटर. 3 मीटर का फासला इनके बीच में लिया जाता है. नेक्स्ट, इफ लाइट इज पासिंग थ्रू होमोजीनियस और आइसोट्रोपिक मीडियम, देन ऑल द वेवफ्रंट्स आर इक्विडिस्टेंट. अगर लाइट किसी आइसोट्रोपिक मीडियम से या होमोजेनियस मीडियम से जा रही है, यानी जिस मीडियम की कंस्ट्रक्शन एक जैसी है, कंपोजिशन एक जैसा है, हर पॉइंट पर वो इक्वली डेंस है, इक्वली रेयर है, तो ऐसे केस में सारे वेवफ्रंट इक्वल डिस्टेंस पर होंगे, यानी ऑल द वेवफ्रंट्स आर इक्वी डिस्टेंट फ्रॉम वन अनदर. But if light is passing through a denser medium, suppose light enters rare to denser medium, then in rare medium wavefronts were at certain gap. Suppose it was 3 meter. Then when light comes in a denser medium, then the gap between any two wavefront becomes less than 3 meter, and as the density increases, the gap also decreases. So we can say in a denser medium, as light passes through denser medium, wavefront comes closer. When light passes through rare medium, the gap between any two wavefront increases. So this is all about the wavefronts. Now let us understand about the Huegens principle. Huegens principle of secondary wavelet. It is a very important principle. This was given by a Dutch physicist, Christian Huegens. Huegens principle is the basis of wave theory of light. This principle tells about how a wave propagates in a given medium, or in other words we can say Huegens principle is the geometrical way to represent the wave propagation in a medium. This principle is based upon 4 postulates. These postulates are as: number 1, a light source is a cause of disturbance or wave in a medium. The wave propagates at equal speed in all directions in form of wavefront. Number 2 postulate: every particle lying on a wavefront behave like a fresh source of a new wave called secondary wave or secondary wavelet. Number 3, these secondary waves spread out in all directions at equal speed, again in form of wavefronts. Number 4, the position of a new wavefront is given by a forward envelope. Forward envelope is a tangential plane that is drawn on secondary spheres. Now we come to the most important, that is Huygens construction. कैसे मैं देख पाऊंगा कि लाइट प्रोपेगेट हो रही है? Huygens construction. Let us first assume that S is a source of light which is spreading the wavefronts in the medium. Let us suppose any wavefront shown by this green line after time t, एक spherical wavefront मैंने t टाइम पर देख लिया. On this wavefront I have assumed 6 points, 1, 2, 3, 4, 5, 6, ये 6 पॉइंट लिए. हमें पता है light is traveling at equal speed in the same medium. Suppose v be the speed of light, light की speed यहां पर मैंने v मान ली है, एंड हमने पता किया है कि अगला वेवफ्रंट डेल्टा टी टाइम पर आएगा. तो व्हाट इज द रेडियस, व्हाट इज द डिस्टेंस कवर्ड बाय लाइट इन डेल्टा टी टाइम? v delta t. So v delta t be the distance between the two wavefronts. Let us draw the sphere of radius v delta t around each particle. These spheres are called secondary wave spheres or secondary spheres. ये मैंने 6 spheres खींच लिए जिनकी रेडियस मैंने मानी है v delta t. अब ये 6 स्फीयर्स खींचने के बाद इनके टेंजेंशियल प्लेन को मैं ज्वाइन करता हूं विद द फ्री एंड. पहला जो वेवफ्रंट मैंने लिया वो रेड पेन से लिया है. ये वेवफ्रंट किसी टाइम टी के बाद, डेल्टा टी टाइम बाद आया था, यानी दिस इज अ लेटर एनवेलप एंड दिस इज द फॉरवर्ड एनवेलप, बैकवर्ड एनवेलप. दिस इज फॉरवर्ड एनवेलप, दिस इज बैकवर्ड एनवेलप. ये वाला लेटर टाइम पे आया, ये टी से डेल्टा टी टाइम पहले आया था. तो दिस इज कॉल्ड बैकवर्ड एनवेलप, दिस इज कॉल्ड फॉरवर्ड एनवेलप. ये फॉरवर्ड एनवेलप इज द पोजीशन ऑफ न्यू वेवफ्रंट. अब अगर मैं इसके ऊपर फिर 6 स्फीयर मान लेता, 6 पॉइंट मान लेता, तो उनके फिर सेकेंडरी स्फीयर बनते, फिर उनका फॉरवर्ड एनवेलप लिया जाता. तो दिस वेव, लाइट वेव प्रोपेगेट्स. कुछ देर बाद अगर मैं इसको मान लूं तो जैसे जैसे आगे बढ़ती जाएगी इनका रेडियस कम होता जाएगा, एंड आफ्टर ए सर्टेन डिस्टेंस or after covering long distance these wavefront becomes parallel. और यहां पर मैंने फिर 6 स्फीयर्स दिखाए हैं. इन 6 स्फीयर्स को मैं सेकेंडरी स्फीयर्स कहता हूं. इनको फ्री एंड ज्वाइन करके मुझे 2 वेवफ्रंट मिले. एक डेल्टा टी टाइम बाद मिला टी से और एक डेल्टा टी टाइम पहले मिला टी से. यहां पर भी हर स्फीयर का जो रेडियस है वो v डेल्टा टी है, क्योंकि मैंने कहा कि पूरे मीडियम को मैंने होमोजेनियस माना है, यानी स्पीड ऑफ लाइट इज सेम एट एवरी पॉइंट एंड हेंस एवरी वेवफ्रंट कम्स आफ्टर डेल्टा टी टाइम, सो द रेडियस ऑफ सेकेंडरी स्फीयर विल बी v डेल्टा टी. तो दिस इज कॉल्ड Huygens construction. I hope you got it. The failure of Huygens principle. Huygens principle का सबसे बड़ा फेल्योर क्या है? Huygens principle fails to explain the backward propagation of light. ये नहीं एक्सप्लेन कर पाता कि why light cannot travel backward, यानी ये लाइट के बैकवर्ड प्रोपेगेशन को डिस्क्राइब नहीं कर पाता. why we take the position of new wavefront in form of forward envelope, why it is not backward envelope. So this is the biggest failure. So this is all about today's class. In the next class we will study about the explanation of laws of reflection and refraction using Huygens principle. By then, thank you for watching. Have a good day.